Okay, today we're doing the review of the Show What You Know from the other day for statistics and probability. So here we go. Okay, first question was who ran 20 meters in 4 seconds? That was similar to the other question the other day, but it was who ran 40 meters in 4 seconds. So for this one, okay, we need to look at the 4 seconds. So that's here. Okay, so covering two of these who ran 20 meters. Now, okay, we have to be very aware that each person has started at a different spot, right? This person, Jack, started at 0, and then the next person started at like the 10. So maybe this is like a track, and there's like different meters as their starting points. So this person started at 10, okay? So let's see first of all, how far Jack ran in 4 seconds. Okay, so he ran from 0 to 40. So he ran 40, right? He ran 40 meters, so it's not him. Then let's look at Kylie. Okay, so she started at 10, and then after 4 seconds, she was at the 40. So what is 4 minus 10? 30. So she ran 30 meters in 4 seconds, so it's not her. Then let's look at Maya. Okay, so Maya started at 20, and then after 4 seconds, she was at 60. So 60 minus 20 is 40. So, right, not her either. So that means we think it's going to be Sam. So Sam started at 30, and after 4 seconds, he finished at 50. 50 minus 30 is 20. So the answer for that one is Sam. Okay, the next question is, who is the slowest runner? Okay, whoops. Okay, so the slowest runner, we don't even really need to do any math for this one. All we need to do is just look at the slope of the line. And this is something that we actually talked about in like the last unit as well. The steeper the line, the faster they're moving, the faster the acceleration, the faster the change. So the people who ran the fastest are the ones that have the steepest of the slopes. If you're thinking of like a slide, right? Like how are you going to get down on a slide faster? Biggest change in height, biggest speed. So Jack and Maya have the steepest, but then who has the most flat? That will be the one who's indicating who ran the slowest. So again, blue, it's Sam. He ran the slowest. And we even know that from our results from the first question. He ran only 20 meters in 4 seconds. Okay, next one is, okay, oh, this was a good question. Okay, so which of the following groups of students should Ali survey for this? Okay, so Ali wants to know if grade 6 students in his school prefer building Lego or playing card games. Okay, so should he survey the students in the grade 6 games club? Well, that's a pretty good option. Let's see if there's something better. All students in grade 6 in his school. Well, and we have to go back up to the question when it's asking to know if grade 6 students in his school. So that is directly related to what's written in the question. If it was, he wants to know which game the game club members prefer, then it would be the students in the games club. But this one would give us the most accurate picture of what he's looking for. So it should be the grade 6 students in the school. It wouldn't just be members of Lego Club, of course. It wouldn't just be members of the card game club, because of course we know they'd have like a bit of a bias or a preference towards the game that they are already registered in. Okay, next one is, okay, so now we're getting into the method of data display. Okay, so how many tubs of popcorn would be sold on Friday, Saturday, and Sunday in Formula One in Abu Dhabi? This should be series of points because, first of all, they wouldn't sell you half a tub, so we only have full values. So that automatically gets rid of the idea of a line graph. Now, the tricky thing is between bar graph and series of points. Now, a bar graph is for categories of things across the x-axis, which can be jumbled up in any order. It wouldn't make sense for us to jumble up Friday, Saturday, and Sunday. It makes sense for us to do this in sequential order. So that makes us know that this would be a series of plots rather than a bar graph, okay? Next one, same thing. Okay, so we're showing the results of the Formula One race cars after they completed 5 laps of the Yas track. So that's going to be a line graph because we would have the speeds. We could get a fraction or a decimal of a speed, and we also would get a fraction or a decimal of the time that they would be like going around the track. Okay, so line graph. The next one is, okay, so the favorite pre-race snack of the top 20 drivers who entered the race on the weekend. So that one should be a bar graph. Oh, I don't even leave you 4 choices. Okay, it should be a bar graph because we could jumble up the favorite snack. We could put licorice, popcorn, I don't know, apples, or we could do apples, popcorn, licorice, and any order. So when it can be in any order, a bar graph makes the most sense. Okay. Next, okay, would we use first or secondhand data to collect information on the number of families planning to attend grade 6 CIS graduation? We could do firsthand data for that because you would be able to collect that information yourself. The next thing is the number of residents of the UAE who have been approved to return since COVID-19 began. That would be secondhand data. There's no way you could figure out that on your own. You'd need to have a second set of help, a second hand helping you. The next thing is the length of time that you brush your teeth for each day. That one hopefully was a bit of a giveaway. It should be first-hand data. You can definitely do that yourself. Okay, next one. Okay, this was actually an old PAT question. Okay, so which tally chart represents the theoretical, that's the key thing, the theoretical probability of Carrie's result? So that means what do we think should happen? So Carrie flips a coin 10 times. She records the number of times the coin lands on heads or tails in one of the tally charts shown below. Okay, so what do we think should happen? Theoretical probability means the most expected thing that we would guess to happen. And of course, that's going to be chart 1, because that's what we think, right? We would assume it would be half-half. Okay, next one. Okay, true or false? When displaying data that is discrete, you would use a line graph. No, you would not. You would use a scatter plot. You would use a line graph to show continuous data. Okay, so that was number 11. Next one, number 12. Whoopsie. Okay, so true or false again. Experimental probability will always be the same as theoretical probability. No, false. There's no way it will always be the same, right? You could do an experiment and you could, like, for example, even like the flipping of the coin, heads and tails, you would not get necessarily what we would expect to get based upon the theoretical probability, as you guys saw probably through your spinner experiments and everything. So that one should have been definitely false. Okay, number 13. Oh yes, this was related to our very last lesson. The more times you do an experiment, the more likely the results are to be the theoretical probability. That is true. That's what we were trying to prove with our massive group experiment with the spinner. The more times that the more data points that we got, the truer we would hope that our results would be to the actual theoretical probability, which is really critical for scientists when they're coming up with for example, like coronavirus cure, right? If they run an experiment over and over and over and over and over and over and over again, that's how they're going to get much more validity behind their data to prove that, yeah, what we've thought, what we've dreamed up in the lab, we know it's actually happening. So we feel confident that when we send this out to the greater public to use, we know that it's going to be what we expect to have happen. So it's the same thing for any type of trial or any type of test. The more times you do an experiment, the closer you're going to get to theoretical probability. So that's true. Okay, the next one is, okay, what is the theoretical probability of winning a point? Okay, all right. So the aliens are playing a game with a spinner like this, okay? To win, the pointer must land on the green planet. Okay, so what is the theoretical probability? Okay, so this one required a little bit of extra math. So first of all, theoretical probability is preferred outcomes, right? How many we want to get over how many there are. So in this one, we want to get the green planet, okay? Two green planets. Over how many different options are there? Well, there's 10 in here, right? So the theoretical probability should be 2 over 10. Do we see that down here? No, we don't, but we can use our prior knowledge of fractions to be able to figure out, well, what is an equivalent fraction? Equivalent fraction to 2 over 10 is 1 over 5. So that the answer for that one is B, okay? Last question. All right. Okay, so how many points would you expect to win in 20 spins? Okay, so you would expect to win in 20 times. So here, we would have, okay, so we'd have to put something over 20, right? And then what would be a comparable probability? This is all expect, right? So this is the in theory. How many times would you expect to win in 20 times? So you would expect to win 4 times, because if the theoretical probability is 2 over 10, if we're finding a different denominator of something over 20, how do we get from 10 to 20? Multiply by 2. So then how do we get from 2 multiply by 2, right? So it would be 2 times 2, 4. Okay, 4. Here you go. So that is it. That was your review. And I suggest that you double check within your inbox to see the screenshots that I would have sent you of this review. Okay, there you go. Let me know if you have questions, if you want to see something more zoomed in or more specifically for what you actually put for an answer, because I can take a screenshot of what you actually put as well, rather than just like the green or red. Okay, nice.